Hello students, and welcome back to another geometry video. You know what to do. Pause the video, try this problem in your notes, and then unpause it to do it with me. Okay, we want to find the value of the variable. We want to find the length of the long leg. So we need to write our answer in simplest form, as usual. So we actually don't even care about the hypotenuse, which is weird. We might do that anyways. We know the length of the short leg, and we want to find the hypotenuse and the long leg. Now, let's do the hypotenuse for fun. So, the short leg, if I want to find the hypotenuse given the short leg, the hypotenuse is just double the length, because this is a 30, 60, 90 triangle. So, the hypotenuse is 2 times the square root of 3. Now, to get from the short leg to the long leg, I need to multiply by the square root of 3. So I'm going to take x is equal to the short leg, the square root of 3, times the square root of 3. What is the square root of 3 times the square root of 3? That would be 3. These square roots cancel each other out. Well, not cancel each other out, but together, 2 square roots of the same thing give us that x equals 3. And there you have it. Nice little review of what we did in the last video. Now let's go ahead and move on to what we have for today. Today we get into section 9.3, and actually this is the only video on section 9.3. 9.3 is about similar right triangles. So, the learning target is that you know what the right triangle similarity theorem says. So similar right triangles, right triangle similarity theorem. So that's what we're aiming to learn, is what is this theorem? What does it say? And how will we know if we understand the right triangle similarity theorem? Well, we'll be able to use it to solve problems, to find side lengths, to dissect word problems, and so on. So we'll be able to use the right triangle similarity theorem. All right. Some vocab that we're going to need for this lesson is the altitude of a triangle. You'll remember this from section 6.3. We talked about it briefly. The point of concurrency where all of the altitudes meet was the orthocenter. So we learned about altitudes when we talked about orthocenters in section 6.3. We learned about altitudes when we need to find the height of a triangle, if we're trying to find the area and we need to find the height of a triangle. So we also talked about them in chapter 1, section 1.4, when we found areas of polygons in the coordinate plane. In the coordinate plane. So, what is an altitude? An altitude is the perpendicular segment. The perpendicular part is important. Perpendicular segment from a vertex of a triangle, one of the corners of the triangle, to the opposite side, or to the line that contains the opposite side. So here in the triangle on the left, we dropped the altitude to the opposite side. This point is on the opposite side. In the triangle on the right, we dropped an altitude, but it's never gonna hit the third side because it needs to be perpendicular. If it hit the other side, it wouldn't be perpendicular. That wouldn't be a right angle. So it's the line that contains the third side. Okay, so that's what an altitude is. It always makes a right angle, and it's from one vertex to the opposite side, or the line that contains the opposite side. All right, we're going to use these altitudes in our theorem. The theorem for today, the theorem for section 9.3, the right triangle similarity theorem. So, what this theorem says is, if the altitude is drawn to the hypotenuse of a right triangle, so if we take the vertex, right, an altitude starts at a vertex and goes to the opposite side. If we start at the right angle and we drop the altitude to the hypotenuse, So if the altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the original triangle and to each other. What? They're saying that if we take this black triangle right here, A, B, C, and we drop this altitude, that means that the original triangle, the one we have right here, and the red triangle inside of that triangle, and the blue triangle inside of that triangle, all of these are similar. The black triangle, the original triangle, the red triangle, the blue triangle, they're all similar. The blue triangle is similar to the black one, the red one is similar to the black one, and the blue and the red triangles are similar as well. They're all similar. How is that possible? Like, what are the odds that every triangle works out that way? Oh my goodness, this is so cool. It's so cool. I remember I didn't learn this when I was in high school. I did not learn this. And I remember talking to the teacher that helped me learn how to become a teacher. I remember him mentioning this theorem, and I was like, what? What? And he was like, yeah, that's a theorem that like we teach. We've taught it for a while. And I was like, not in my school. That is so cool. So I really like this theorem. So our first example is being able to pick apart. We want to be able to look. We can see that we have a right triangle. We have RST, and we can see that there are two other right triangles in here. There's triangle RUT, there's this triangle, and there's triangle SUT. And we know that the black triangle, the original triangle, the red triangle, and the blue triangle are all similar to each other. This first example wants us to be able to take a triangle and split it apart and identify the similar triangles. So they want us to identify the similar triangles. So what they want us to do is they want us to say triangle RST is congruent to triangle blue, which is, or not congruent, I'm sorry, which is similar to triangle red. So I'll do this. They want us to write a similarity statement and to identify each of the triangles. What order am I supposed to write these in? Right? Remember, when I write a similarity statement, I need to write the triangles, the vertices of the triangles. I need to write them in order of their corresponding pieces. So angle R corresponds to what vertex for the red triangle and what vertex for the blue triangle. That's very hard to see in this picture. That is very hard to see. So what we're going to do is we're going to draw each of these triangles in the same orientation. So we're going to have triangle, this is our original triangle, RST. This is our original triangle. Now, I know that the red triangle is similar to this one. But which vertex goes where? We know that U is at the right angle, right? Here's the right angle, and U is right next to it. So U is at the right angle. Then, notice R is still the really small angle. R is still the pointy, the smallest angle. So that's R. Whoops. And then T, we can see that T is the other corner of the triangle. Cool. So now I can see that the black triangle went RST, and the red triangle needs to go RTU. And I want it to be all red. So there we go. RST, RTU. Now, we just need to do the same thing with the itty bitty blue triangle. Little blue triangle. So again, we can see that U is still at the right angle. We can tell that T is the really teeny, pointy, small angle, and then S is the third angle. So the black triangle goes RST, the red triangle goes RTU, the blue triangle needs to go TSU. I strongly encourage you to draw the pictures out like this. It's confusing for me, y'all, and I teach math and I have a math degree, and it is difficult for me to see what's going on just from this diagram. Like, I need to pull it apart. So, you should also pull the triangles apart so that you can see exactly what piece corresponds to what piece, so that you can write your similarity statements accordingly. Now, let's check our answer. So, sketch the 3 similar right triangles so that the corresponding angles and sides have the same orientation. So they have triangle RST, that's the original, and then they have RTU, which is our red triangle, and then they have TSU. Yes, TSU, that's what we had. So this is their red triangle. This is how we did it. Okay, whoops. Wonderful, so we were correct. Hey, give me my red triangle back. Okay, wonderful. So we wanted us to identify the similar triangles, and that's what we did with our similarity statement. Yay! Okay, but we haven't found any side lengths, right? Our success criteria said that we needed to use this right triangle similarity theorem to find side lengths, to solve problems. So, here is a problem that we're going to solve. A roof has a cross-section that is a right triangle. A cross-section means if you cut the house in half, this is what the roof looks like. Or I guess even if you look at it straight on, that's what it looks like. So it has a cross-section that is a right triangle. The diagram shows the approximate dimensions of this cross-section. Find the height of the roof. Well, this could be helpful. This could be something that you'd actually want to do if you were trying to, I don't know, hang a sign on the front of your house. You needed to know how much space you actually had to hang the sign. But, like, how are you going to get your tape measure up there without, like, I suppose you could try to crawl on the roof and lower it down, but then somebody's got to be on a ladder. Like, whoa, that's a lot of work. So we could use the right triangle similarity theorem to figure out what the height of the roof is. But there's a lot of stuff going on here. We know that the house is 6.3 meters wide. This side of the roof is 5.5 meters long, and this side of the roof is 3.1 meters long. And we want to find the height. So, I need to draw some other triangles. I need to be able to see what's going on here. So, let's draw our triangles. I'm going to draw the original roof right here. Z, Y, X. We have 3.1. I'm going to drop the meters for now. We can add the units back in later. But here's my original triangle. Now, let's take the left side. We'll take the left side. And remember, it's going to be, because these are similar, we know they're similar, it's going to be in the exact same shape, just a different size. Now, the right angle is at W. The smallest angle is Z, and the other angle is Y. Okay. And lastly, we have the triangle on the right, which again we can draw in the same orientation, same size, or excuse me, same shape, different size. So W, again, is still at the right angle, Y is the smallest angle, and X is the one left over. So notice that we did exactly what we did in the last example. except we are not writing a similarity statement. We're gonna label the sides. So, oh, whoops, we forgot to do that for the red triangle. We'll come back to that. But for the blue triangle, xy is 3.1 meters. So xy is 3.1 meters. And yw is h, is the height. And then we don't know what wx is. So I'm just going to leave it blank because we don't know. Back to the red triangle. We forgot to label that. My bad. We know that zy is 5.5 meters. And yw is h, the height. And we don't know what zw is. Okay. Cool. Now what? Well, now we know that these shapes are similar. What's so special about similar shapes or similar triangles? Their side lengths are proportional. Their angles are congruent. Their side lengths are proportional. So we can write a proportion. Which triangle do you like better? You like the red triangle? You like the blue triangle? I don't care which one we use. I'm going to pick the red triangle because I can. We can pick the blue triangle if we want to, though. We can totally do that. But I know that the side that's on like the top right, these are corresponding sides. So they need to be proportional. And the other side, the bottom sides, or the bottom of the roof, the width of the house, also needs to be proportional. So the ratio, if I'm comparing 5.5 to 6.3, that ratio needs to be the same as h to 3.1. This is exactly like chapter 8, 8.1, 8.3. Yes, sides are proportional. So we're going to compare, right? The red triangle stays on top. We have 5.5 and h. Those are our red side lengths are on top. And the black triangle goes on the bottom. So we have 6.3 and 3.1 on the bottom. Now, we're going to cross multiply. 6.3 times h equals 5.5 times 3.1, which is 17.05. Divide by 6.3 on both sides. Divide by 6.3, and we get that h is approximately 2.706, blah, blah, blah. So, what does this mean? What does h equals 2.706 yada yada mean? It means the height of the roof is about 2.71 meters. I told you we were going to bring the units back, meters. So, let's summarize what we did. We picked apart our similar triangles so that we could see which sides were corresponding to which. Then, we picked two triangles. We knew we were going to work with the black triangle because the black triangle has all of the side lengths. 5.5, 3.1, 6.3. Notice how the red triangle was missing a side and the blue triangle was missing a side. So we can't put the blue and the red triangles together because h doesn't correspond to anything on the blue triangle. So we couldn't use the blue and the red. We had to use the black triangle. And then we picked whichever one we wanted. We picked the red one. We put red on top, black on the bottom. We could easily have picked the blue triangle and put blue on top, black on bottom, black on top, red on the bottom, whatever you want. And then we cross-multiplied and we solved for h, just like we did in section 8.1 and 8.3 in chapter 8 with our similar figures. So, let's check and see if we were correct. Let's see. They drew their similar triangles as well. They drew them in a different orientation than us. That's okay. We drew them in the shape of the roof. They kind of like stood them up on end. That's fine. Whatever works best for you. But because these triangles are similar, we can write a proportion. So, that's what they did. They used the middle triangle and the big triangle, which is what we did. This was our red triangle, our blue triangle. And they got about 2.7. We said 2.71. If we rounded to the 10th, we also would have had 2.7. So, doesn't matter if we... they didn't tell us what to round to, so it's okay that we had 2.71. But yeah! Wonderful. The roof is about 2.7 meters. And they checked their answer by saying, the height of the roof is the leg of the of the red triangle, and is a leg of the red triangle and the blue triangle, so it needs to be shorter than each of their hypotenuses. So it needs to be shorter than 5.5 and 3.1, and it is. It's shorter than all of the hypotenuses. So, our answer seemed reasonable. Anytime you can find a way to check your answer, go for it. Knowing, like having some sense of security and calmness that yes, this answer seems reasonable. If we had gotten 15 for our answer, we did something wrong. Because there's no way that the height, like if this part is 5, there's no way that this should be 15. So, it's always nice to know that we got a reasonable answer. Can give you a sense of calm about your answer. Alright. That is all I have for you today. So, you know what time it is. It is time to rate yourself on a scale of 1 to 3. Do you understand the right triangle similarity theorem and how to use it to solve problems, to write similarity statements, to find heights of roofs and side lengths in triangles? Do you think you got it? Not 100% sure? But you want to try the homework? Or are you totally and completely lost and you need to ask for help? No matter where you are, awesome job. Because if you're here and you're watching this, it means that you're trying, that you're really trying to understand. So, take the appropriate action that you need to take, but know that the fact that you made it to this part of the video, I am proud of you, just for making it to this part of the video. So, take the appropriate action, ask questions, try the homework, help your friends and family, and look at these practice problems. Oh, that should not say homework. This is not necessarily your homework. These are just practice problems that you can do to help assess your understanding of the learning target and success criteria. If you can do these with no problems, with no questions, you're a 3. If you can do most of them, you're a 2, and if you don't even know where to start, you're a 1. Okay. Today's launch comes from Dana Stewart Scott, and she says, "Learn as much as you can while you're young, since life becomes too busy later." I can testify to this. I wish that I had spent more time studying when I was in college. I wish that I had paid more attention to the learning in high school. In high school, I was all about the grades. Just give me the grade. I just need to pass. I just need a good grade. I didn't really care about what we were learning as long as I got a good grade. Now, I have a job. I have a house. I have a little family. I have, things I gotta do. I have bills I gotta pay. I have other responsibilities I have to deal with. And life is very busy. I have friends I want to do things with. Life is very busy. I don't have as much time. I still have time and I make time to learn, but I don't have as much time to learn as I used to. In college, I had so much time. And I had fun in college too, I spent time with Mr. Dodge. I got to know him. That was wonderful. I went on hikes. I had friends. I danced, all that stuff. That's good. But I wish I had truly taken the time to dig into my studies and use the resources. Like now, I don't have a differential geometry teacher that I can talk to about any questions that I'm having that can guide me through the book. Now I just have to look at the differential geometry textbook and go, I think I understand this. I'm not 100% sure. I think I understand this. Like, and it's not as easy to learn as it was before because I don't have the resources and I don't have the time. So I'm going to get off my soapbox now. This launch is getting a little long, but take advantage of the opportunities you have to learn now while you are young, because life becomes busy later, and the more you learn when you're young, the more you can learn when you're older, right? Learning like builds off of itself. You can apply your learning, you can connect different things that you know, and yada yada. So I'll get off my soapbox, but really take advantage of the opportunities that you have, the classes that you have, the clubs that you go to, the sports you participate in, anything else, any other extracurricular stuff, and ask yourself, if you're not taking advantage of the opportunities that you have, how could you in the future? So that is my launch for you today. Take it with you as you go throughout your day. Have a wonderful rest of your day, and thanks for being here. Thanks for watching. Bye.